Hello everyone and welcome to ixamBee. So in this video we are going to talk about the important concept of tree. In SEBI IT there are many important concepts and we are bringing this initiative of coming with important concepts related to SEBI IT exam, and we are starting with the most important concept, that is tree. It is very important as part of your mains examination, and it is truly important for your preliminary examinations as well. So this topic is the topic which is a must do topic for every aspirant. So we are going to start from the very basics, as this is the part 1 of the tree. You are going to learn some concepts, and in the upcoming videos we are going to dig deep into this particular tree, and we'll see some of the coding questions and some of the phase 1 questions as well. So this is our path to carry on with this particular important concept series. Hope you will enjoy this series and this will bring knowledge to you. So let's start with the video. So tree is a data structure. Okay, data structure, if it is, then it will have some kind of property, some kind of characteristics, and it will be having some distinguished features that will enable the tree to be an important data structure apart from others. Okay, so first we will understand about the tree. So tree is a non-linear data structures used for the hierarchical structures. Like if we are going to have the hierarchical structures, we are going to have this non-linear data structure that is called as tree. So it is non-linear and it is used in the hierarchical structures. Other than that, what establishes a tree or what a tree contain is like nodes, and tree will have nodes, and every node will have the pointers to its left and right node. Okay, so the tree is going to be like a recursive orientation of nodes. One node will have left node and right node, and then simultaneously the further nodes will also have the left and right nodes. So every node here will have the child nodes. One node can be a parent node, other nodes will be leaf nodes. So there are some kind of terminologies that we need to understand. As you can see in one of the figure which is shown right here, you are going to have a tree where A, B, C, D, E, F, G, these are the nodes that are in the tree. So you can see A is the parent node, which is the special node that is called as root. So from where the tree is going to start, we call that node as root node. It is also the parent of B and C. Okay, here B and C will be the left child and the right child of A respectively. And D, E, these will be siblings because they belong to the same parent. In the similar manner, F and G are also siblings, B and C are also siblings. Now, if I bifurcate the part of B, D, E, it will be called as the left subtree. It is a subtree, right? We have the entire tree, and if we cut out some part of that tree, it will be called as a subtree. So we have a left subtree that will be called as a combination of B, D, E, and we have a right subtree that will be called upon the combination of C, F, and G. So these are the basic terminology that one need to understand. Apart from that, the connecting nodes will be done by edges. Okay, so everything that is going to play a role of the connection is called edge. So here A and B are going to get connected by a edge that is between A and B. That is the line as shown in the figure. Okay, so I hope you understand the vocabulary of the tree. Now, what are the applications of the tree? So we have many applications of the tree, and some of them are like manipulating the hierarchical data. So whenever we are going to have the hierarchical data, it is for our understanding, and it is given to us in the format of tree. Okay, so tree plays a very important role when we need to organize or play around with the hierarchical data. It makes information easy to search. Okay, so when we will going to see the traversals in the tree, we are going to understand that how it is easy to search in the trees. Apart from arrays, linked list, stack, or queue, the complexity that is involved with the searching operation in the tree is very less as compared to the other data structures. Now, manipulated of the sorted list of the data. So trees can be also used in order to store the data in the sorted manner. We have binary search tree which maintain a specific kind of order. In upcoming videos, we are going to study about that as well. By this time, you just need to know what are the applications, and one of the application involves this thing, that is the storing of the data in a sorted manner. After that thing, in the routers algorithm, trees are used in a very large scale. Then they also form a multi-stage decision making. You know that there is something called as decision tree, knowledge tree that is made here, and in the data science as well there are many applications of clustering and these things. So trees are data structures wherever we can use a multi-staging data decision making. That will be very helpful if we are going to use tree in their cases. Okay, after that thing we have trees in the compiler, because we have the expression trees, we have the arithmetic expression, uh, and we have some exponential expressions, we have logical expressions as well. So in the calculation of all those things we have the compilers. Then we have the Huffman coding, and in the Huffman coding the data compression algorithms happens, and that will also take help of the trees. Then priority queues are another application of the binary tree, and it is used for the searching maximum or minimum number in the less amount of time complexity, that is bigger of 15. So these are the important statements that can come in the preliminary examination as well as in the interviews. Okay, so I hope these particular points are clear to you. Now the next thing that comes into the scenario is the traversal in the binary tree. So there are many types of traversal. There are major three types of traversal that is called as pre-order traversal, in-order traversal, and the post-order traversal. So the pre-order traversal is like, we know that we are going to have root, then left node, then the right node. So how we are going to iterate through these three is going to make the traversal in these three orders. Okay, so in pre-order we have to first visit our root node, and then we have to visit the left child and the right child, and we have to do this thing recursively, and once we reach all the end then our things will get done. The next one is the in-order traversal. In in-order traversal, what we are going to do, we are going to have a left child first, then the root, and then the right child. And in the post order, we are going to iterate through the left child, then the right child, and then the root. So you can see here what is going to be fixed in all the three is the point that all the left childs are going to get iterated before the right childs, right? Only the thing that is going to change is the root. So in pre-order, first root is the thing that is root. In order, it is the mid one, and in the post order, it is the last one. But every time the left part is going to get iterated before the right part. This is the fixed thing, and this thing you have to keep in mind in order to solve the equation and in order to write the codes for the traversals. After that thing, let's see one of the example to understand the in, pre, post. And there are two more traversals, that are the DFS and BFS. We are going to learn about the DFS and BFS when we are going to discuss the topic of graphs. But as of now, I will just give you how this BFS and DFS are going to get their own traversals. So in order traversal, here you can see what it is coming here. You can see here the thing that is coming here is 4. So we know that first every thing that is there in the left will get iterated. So you can see 4 to 5, these are the things which are in the left, so these are coming first, then 1 is coming, that is the root, it is in middle, and then 3, 6 and 7 are in the right part. So 6, 3, 7 will be the order. You can see here in the 6, 3, 7 part, 6 is coming first, then 3, and then 7. So inside the sub-tree parts, we are going to do the traversal in the manner where we are going to stick to the left, then root, and then the child. In similar manner, the pre-order, here the node of the root will come first, then the left part, and then the right part. In the left part, first the left root node will come, and then the remaining left child and the right child will come. So 2, 4, and 5 will order in the left part. Similarly, in the right part, it will be 3, 6, and 7. In the post order traversal, you can see it is 7, 6, 3 in the thing. So here what we are going to have, first we are going to have the right part. The right part, the rightmost part, that is 7, then 6, and then 3, because root is going to be the part at the end. And here you can see 1 is coming at the last, because the roots are going to get iterated at the last, and it is the post order traversal. Then we have the BFS traversal, that is the breadth first traversal. So in breadth first traversal, what we are going to do, we are going to iterate through the width of the tree, and width of the tree followed the order 1, 2, 3, then 4, 5, 6, and 7. We are not going in the depth first, we are going in the breadth first. So that's why it is called as breadth first traversal. In the depth first traversal, what we are going to do, we are first going to dig deep down and reach the leaf node, and then we are going to come up. So we are going to do the traversal in the heighted manner, that is 1, 2, and 4, and then coming back it is 5, then 6, then 3, then 6, then 7. So this is the area how the DFS and BFS are also into scenario. If you don't understand DFS and BFS right now, do not panic. We are going to bring videos on the graphs, and there you will be able to understand this BFS and DFS as well. Now Coming to the properties, which is the last slide of this particular video, is the thing which you need to take care and understand the tree in a better manner. So the maximum number of nodes at any level L of a binary tree is 2 to the power L. So if I give you any level of the tree and I ask you how many nodes are there, that is the maximum number of nodes in the binary tree. So you have to tell me 2 to the power L. Then maximum number of nodes of a binary tree of height h is 2 to the power h minus 1. That is the number of nodes that the binary tree will contain of height h. Then in the third point, in a binary tree with n nodes, the minimum possible height or the minimum possible number of levels that are going to be there will be log base 2 n plus 1. So if I give you the number of nodes and I ask you to maintain a binary tree in a minimum leveled tree, you will have to give me the levels as log base 2 n plus 1. And the last point is of regarding the non-empty binary tree. And here what we are going to have the total number of nodes, that is E. Then the total number of nodes will be n and the edges will be E. Then you are going to have a relationship that is E equal to n minus 1. These things are very relatable. Even if you take any binary tree and you try to apply these particular points and you are going to play around with the numbers, you will be understanding these in a better order. So this was all from my side for this particular introductory video of the trees. Hope you gained some knowledge. What you're going to do, just try to solve some order traversal problems and understand the in order, pre-order and post-order. Do learn the properties and the application because they can come in the preliminary examination as the statements. So these will be important for your exams. And there is one announcement for our side, from our side, that is the grade A level of the SEBI course is with us. Okay, so we are running this course from past 2 years and we are getting a good response. What you can do is like go and try this particular course, get the demo thing, and then you can just go to our website, try our course content, go to the previous year paper. There is so many things that you can do. The list of the course providing things are here, like video lessons, the study notes, practice tests, live session, interview guidance. These things are with us. That is on us. We are going to provide you these things in our course. That is the SEBI Grade A IT Officer online course. So enroll now if you want to reap the benefits out of this course. If you like this video, do hit the like button. It will be a motivation for us to bring such more videos. And also, if you're not a subscribed user, please do hit the subscribe button in order to get the regular update from our side. In the meantime, till we bring the next video, stay updated and keep practicing.